right, this is lesson 7.3. It is the law of cosines. The first two sections are the law of sines, and hopefully you've gotten pretty good with that. And now we're going to move on and do the law of cosines. And again, our whole goal in this chapter is, can we solve triangles? And you think back to the triangles with law of sines, it would work when we were doing side, angle, side. Did I say that right? I'm sorry. For law of sines worked for angle, side, angle. It's right here. So when we had angle, side, angle, or side, side, angle, we could use the law of sines. But remember from geometry, there's other ways that they can give you three pieces of information. They could give you a side, angle, side, or they could give you a side, side, side. And if they give you either one of these sets of three pieces of information, law of sines is not going to work. You need something else. And that something else is right here, law of cosines. This one I'm not going to derive, but I'll just tell you what it is. And there's kind of three versions of it. They're all analogous. So once you get one version, the other two are just like it. But the law of cosines goes like this. It's got a squared equals b squared plus c squared. Or down here, look, c squared equals a squared plus b squared. And that first part might look kind of familiar because that looks just like the Pythagorean theorem. And you think, well, wait, Pythagorean theorem, why can't I use that? Because that only works for right triangles. And so now what happens is we have that Pythagorean theorem, but because this is for all triangles, it becomes more general. So you've got this beginning, c squared equals a squared plus b squared, but if it's not a right triangle, you have this other part here, minus 2ab cosinus c. And again, if angle C happened to be 90 degrees, what's the cosine of 90 degrees? Cosine of 90 degrees is 0. And this whole thing goes to 0. And sure enough, you would have the Pythagorean theorem. So this is really just a more general statement of the Pythagorean theorem. And it holds not just for right triangles, but for any triangle. Okay, just like law of sines, you noticed, wow, you had two letters the same. Law of cosines, you want to kind of notice, wow, you have all three letters. So it's side A, side B, side C, or side A, side C, and then look, angle B. Side B, side C, look, angle A. So this is going to be much more effective when you have three different letters. It will work for side, 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 because clearly if I gave you three different sides, that would be three different letters. And side, angle, side as well. Those are three different letters. It's a side, the included angle, and the side. Those will be three different letters. So we're going to apply the law of cosines in those types of situations. For side, angle, side, and side, 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 we'll have another section, kind of an addition to section 7.3, where we talk about that. When do I use law of sines? When do I use law of cosines? Okay, one more fact, and we'll start. Fact is, if you use the law of cosines as step one, you're never going to have to worry about that ambiguous case that we had to worry about with sines. All right, and the question would be, why won't you have to worry about that? And the best reason is because you use the law of sines when it's side, angle, side, or when it's side, side, side. And both of those were legitimate geometry proofs of congruence. And so if I give you those three pieces of information, side, angle, side, or side, 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 you've pinned it down. It is only one, there's only one possible triangle for that. And so there will be no ambiguity when you do that. If you look back at law of sines, when you're doing side, side, angle, that was not a legitimate geometry proof for congruence. And so you couldn't pin it down to just a single triangle under those circumstances. All right, so let's try this. We've got a triangle here. We've got angle A is 41.4. We've got side B. We've got side C. And again, you'll notice three letters that are different. And when we put this all together, I'll show you one case where there's three different letters where you don't use law of cosines. But in general, it kind of leans you that way. You could draw a picture and realize this is side, angle, side. But we notice those three different letters, and so I'm going to write down the law of sines, and there's three versions. But I'm going to write down a version with the a squared equals b squared plus c squared minus 2bc, and it's a cosine of a. And why would I choose that? Because look, I've got angle A, B, and C. I'll choose that version. Okay, what should we get first? Well, kind of looks like we're getting side A first. You don't have a lot of choice in the matter. So a squared equals 2.78 squared and 3.92 squared minus 2 times 2.78 times 3.92 times the cosine, and angle A is 41.4 So times the cosine of 41.4 degrees. All right, is it really this simple? It is. Let's just pop this into our calculator and see what we get for this. I'm going to scoot that over just a little bit. Don't have too much from there, do I? So we still got that 2.78 squared. Again, check your mode. Make sure your mode is in degrees when we're doing these triangle problems. That's a switch from graphing when we're in radians. And let's try this. 2.78 squared. And then we've got a 3.92 squared. Minus 2 times 2.78 times 3.92 times, and I don't need the times, I'll just go cosine. I'll put in 41.4. And again, I see side B is 2.78, side C is 3.92. I wonder what side A is going to be. Hit enter. And at first you're thinking, ooh, that's kind of big for side A. But guys, don't forget, that was really A squared. And so now that we've done this much, don't forget to take the square root. So I'm going to take the square root of that, 6.74. And I come up with if we round this to two places, 2.60, 2 decimal places. So side A equals 2.60. All right. Are we done with the problem now? No. Solve a triangle means find everything. So I still need to find angle B. I still need to find angle C. To do that, I could use the law of cosines again. Or to be honest, I think in a case like this, the law of sines is a little easier for step 2. So let's apply step 2. And this would be kind of important with the law of sines because when we're looking for angles, you're going to take the sine inverse. You're going to have that, should it be the first quadrant answer or the second quadrant answer? So if I was doing the law of sines, I'd always find the smallest angle. So I'm looking for angle B and I'm looking for angle C. Here's side B, here's side C. I'm going to find angle B with the law of sines. So law of sines, I would always find the smallest. Law of cosines, we're always going to find the biggest. We'll see that in the next problem. So I'm going to write the sine of B over side B equals, and now I've got A kind of pinned down here. So the sine of 41.4 all over 2.60. At this point, you're good at cross multiplying and dividing. So I'll get the sine of B is 2.78 times the sine 41.4 divided by 2.60. I'll get that, and don't forget to take the sine inverse. And again, I'm not worried about, no triangles or two answers or whatever. I should get one answer here. So let's go 2.78. I've got the sine 41.4. And I'll divide that by 2.60. Get that answer. I'll take the sine inverse of it. And I come up with angle B. If I round that, oh, that's so tempting. Let's round that to 45 degrees. So angle B equals 45 degrees. Now, there's got to be good trig students out there saying, wait a minute, when we take the sine inverse, we're supposed to say or. And you can say or. And you can go 180 minus 45 and say, wait a minute, what about 135 degrees? But guys, we can shoot that one down. We set up here, we were finding the smaller of the two angles. So side C is bigger than side B. Angle C is going to be bigger than angle B. So there's no way any triangle would have room for a small angle of 135 degrees. So by using the law of sines to find the smallest angle, there's no ambiguity. There's no way a small angle is going to be in the second quadrant. So angle B is 45. Let's keep track of that. And then angle C is easy. Let's go 180. We'll take off the 45. How much was angle A? 41.4. And we get angle C equals 93.6. And I'm glad I didn't use the law of sines to figure that one out, because I would have gotten an 87.4 or 93.6. I wouldn't have known what to take. So very important, use law of sines to get the smaller angle. And then there's no ambiguity, no way it would ever be that second quadrant. So there we go. We've solved the triangle. I'd like to show you just one more problem. It's still law of cosines, but one more thing to it. I don't know if we'll finish it or not, but we'll certainly start it. So here's a triangle. They give you just three sides, side A, side B, side C. Now, I'm going to use the law of cosines. I have three different letters. When I'm using the law of cosines, I want to find the biggest angle first, because then in my second step, when I'm using the law of sines, I'll be finding the small angle, and I won't have to worry about it being ambiguous. So just a good habit to do. Law of sines, find a small angle. Law of cosines, find a big angle. All right, so we're going to set this up. And I will set it up, since I'm looking for angle C, I'm going to go C squared equals A squared plus B squared minus 2AB cosine of C. All right, the algebra is a little trickier here. C squared is 8, 8 squared is 64, A is 4, squared is 16, B is 25, minus 2 times 4 times 5 times the cosine of C. All right, we'll do a little bit of algebra, a little bit of arithmetic on the right. 16 plus 25 is 41. I multiply these three, that looks like 40 cosine of C. And I've seen people in the past make mistakes here. They'll try to put the 40 and the 41 together. They don't go together because of the order of operations. This is connected with multiplication. So my next step is subtract 41 from both sides. Looks like a 23 is a negative 40 cosine of C. That negative might bother you, but let's just live with it. Divide by negative 40. I get negative 23 over 40 is a cosine of C. And if I think about a smart trig class, that negative doesn't bother me for a cosine. It just means I'll have an answer in the second quadrant. The sine is positive in the second quadrant, but the cosine will be negative. Okay, let's find angle C. Clear that off there. I'm going to take the cosine inverse. And I forgot my number already. Let's see what that was. Cosine inverse of negative 23 over 40. So negative 23 over 40. And this will give me the angle measurement for C. And it looks like angle C is 125 degrees. We round that. So angle C is 125 degrees. Then let's use the law of sines to get angle A or angle B. And again, because I've already found the biggest side, I'm not worried about the other two. I'll just write one of these, but I don't know if we need to finish this because we've done this before. So technically, I would find with the law of sines, angle A, it's the smallest one. So I would go sine of A over 4 equals, and then we've got the sine of 125. I forgot side C already. Sine of 125 all over side C is 8. And you guys can cross multiply, you can divide, and you can finish that. Let's just see what we get for an answer. We'll do that very quickly. Would you guys agree? I've got 4 times the sine of 125. Agree I divide by 8. And I'll take the sine inverse of that. And I'm not worried about the or, that's 24. There's no way it would be in the second quadrant. This was a small angle. So we've got A is 24 degrees. I can also get angle B because I know there's 180 degrees in a triangle. 125 and 24 give me 149. So it looks like angle B is 31 degrees. So we've solved this triangle. We've gotten the three angles on this triangle. There's a little bit more with Huron's formula. I won't show you that part today. We'll do that part tomorrow. We'll add that in. But this is the main application of the law of cosines. So it works for side angle side and side side side.